Alright, so this video will be about graphs and what information you can get from graphs and how to use graphs. So basics of graphs will be covered in video. Now I like Indian food, okay? Although I don't know how to make it, but I have a basic understanding of how an Indian meal is prepared. So there's something called spices that are really important, okay? So if you're making a biryani, for example, and biryani, okay, I'm definitely biased, but I'm gonna just say it. Biryani is the best food in this world. Anyways, to get that food right, you need to have basic ingredients present, and which is basically different kinds of spices. Now, if you don't nail those spices down, your biryani would just be like fried rice, and you will not really enjoy it. Okay, so point being, if you have ever had a biryani and you never enjoyed it, chances are the ingredients used were not correct. Otherwise, you would have loved it. So, what ingredients are to that biryani? These prerequisite videos are for this course, 211 or 231 or whatever course and you're taking physics or mathematics. Now, one of those ingredients is graphs. If you're able to understand graphs and if you can pick out the right information from the graph, you will be able to understand more complex subjects and you will be able to solve problems. That is why graphs are important. Now, you have seen graphs. Graphs basically they come in different kinds of sizes and shapes, but we'll be talking about especially two-dimensional graphs, which is the graphs that you can make by having two perpendicular lines like this, okay, and you basically have like a squiggly line between those two lines or around those two lines, which tell you the behavior of how one axis changing with respect to another changing. Oh, I'm sorry, changes with respect to the other one changing. So you can have, let's say, let me write down the heading. It's graphs. Okay. So let's say on the y-axis is generally the vertical axis. We have got position, and I'm gonna call it x. That's weird. But a lot of times we call position x. So in the y-axis I wrote down x because that is that is my position axis. I hope it makes sense. And on the x-axis, which is the vertical axis, I'm gonna plot time t. Okay. So if let's say how should I do it? Let's start with an example. Now I have an equation that tells me a position of a particle with respect to time. Okay, let's see. Let's say that equation is x equals 2t plus 1. Okay, now you can plot this equation on this graph and you get a more let's say graphical picture of what is happening to the position with respect to time. Okay, let's see how you plot these kind of equations. You can make two tables, t and x, t being time in seconds, let's say. So at t equals to 0, well, x is equals to 2t plus 1, right? So at t equals to 0, x equals to 2 times 0 plus 1, and that gives you 1. At t equals to 1 second, so see what I'm doing. I'm just solving the equation. I'm plugging in different values of t to get different and corresponding values of x, and I'm going to plot those values in the graph of x and t, or distance time graph or displacement time graph. We're going to study a lot more about these graphs, but just for now understand that there's an equation that tells me how one thing on the left hand side is changing with respect to other thing on the right hand side. And for us, that thing changing is the position with respect to time. So for t equals to 1 second, x is 2 times 1. I'm just solving this equation. Plus 1 is going to be 2 plus 2 times 1 is equals to 2 plus 1 equals to 3. At t equals to 2 seconds, I have x equals to 2 times 2 plus 1 that is 5. Let's do one more. X equals to 3. I'm sorry, t equals to 3 seconds. I've got 2 times 3 plus 1, 7. So if I want to plot this on this xt graph, I would have, let's make these markings. So t equals to 0 is here, 1 second is here, 2 is here, 3, 4, we don't need any more. And on x, let's say this is 1, 2, 3, 4, 6, let's say this is 7. So at t equals to 0, x equals to 1. So that point is this one, 0, comma 1. At t equals to 1, x is equals to 3. So it's t equals to 1, x equals to 3 is this point, 1, comma 3. At t equals to 2, x equals to 5. So at t equals to 2, x equals to 5. So it's this point, 2, comma 5. At t equals to 3, x equals to 7. So that point will be here, 3, comma 7. That means that we now can see graphically on this xt graph how the position of the particle is changing with respect to time. Now to make it more pretty, you can just make a straight line like this. Okay, so if the behavior continues, now you know exactly what, without calculating, in principle you can figure out what position is at t equals to 4 or t equals to 3.5 and so on and so forth. So that's how you make a graph, and that's the information that you can get from a graph. Now let me see what else I need to talk about. Alright, so you've got a graph like this, right? There's an important concept called slope, which you will be using a lot. And in order to say something about it, I need to copy this graph. And let's say this is our graph right here. And I'm talking about slope. So let's write down that here. Now slope is given by y2 minus y1 divided by x2 minus x1. It's going to make sense in a minute. Let's say I'm talking slope between these 2 points. Okay, let me just highlight that region. So I'm talking about this region. Here, if I want to figure out the slope, what I will say is that from here 3 comma 7 is 3 is the x value and 7 is the y value. So x2 is 3 and y2 is 7. X1 here is 2 and y1 equals to 5, right? So slope here will be just 7 minus 5 divided by 3 minus 2. This gives you slope to be equal to slope to be equal to 2. So that is the slope between those 2 points, 2 comma 5 and 3 comma 7. So that's how you figure out slope. Now there's a different formula, or I should say a way to look at slope, and that is if you make a horizontal line like this, and let's say this angle is theta, so slope is equal to tangent of theta. That you will probably know or have seen earlier what tangent means. So tangent of theta, where theta is this angle. So if I need to figure out what is that angle in our example, I can use the formula which says that tangent of theta equals to slope, and that is, as we calculated, 2, or theta can be written as tangent inverse of 2, and this gives out 63.43 degrees. So we have just figured out slope first, and then the angle of that line segment with respect to horizontal using that slope. Now this example is of something called a straight line, because we plotted this equation here, and the answer we got on a graph was this is straight line, right? But then you can also have different kinds of equations. They will give you different kinds of graphs. Okay, so let's look at this one. Y equals, let's say, let's do a different one. X equals 2t square, and again let's have two columns. T equals to 0, t, and then x. T equals to 0 will give you 0, t equals to 1, x equals to 2, t equals to 2, 2 times 2 for 8, and that's how you get different points. So if you plot this one here, and you can do this as an exercise, what you'll see is your behavior will be something like this. Now this is called a parabola. So if you already know what parabola is and doesn't seem familiar, that is because I've not drawn the other half, and that is this one. I've not drawn that other half because physically it doesn't make sense, because that is the negative t-axis, and value of time being negative doesn't really make sense. So that's why I haven't drawn that negative t. But this you get for this equation 2t square. So depending on the equation, you get different kind of graphs. And one more thing we covered is what is the slope of a graph in a very simple term: y coordinates, difference of y coordinate divided by difference of the x coordinates. And that is all about it.